Good afternoon. This is Victoria Beal with the Ohio LTAP Center, and I want to welcome you to this afternoon's webinar. We have Derek Troyer with us from ODOT's Safety Section, and he's going to be presenting a webinar on understanding Ohio's crash data and how to make sure your agency's crash data is correct. We're really pleased to be able to offer this webinar this afternoon. A couple of housekeeping items. You might have noticed when you joined that you're in listen-only mode. At the end of the webinar, I will unmute the phone lines, so those of you who would like to ask questions via the phone line can do that. While we're in the webinar, though, and Derek's presenting, we do ask that you type any questions you have into the chat pod. If the chat pod isn't already available on the left-hand side of your screen, you'll probably see a small round circle on the bottom left-hand corner that has a thought bubble in it, and if you click on that, it should display the chat pod on the left-hand side of your screen. So we are also attempting to record the webinar. If it's successful, I will make certain to send a link out to everyone. But please don't let that dampen your enthusiasm for asking questions. If you have a question, I am certain that there are many others who have the same question, and it benefits everybody to have the questions asked so we can find out the answers. So with that, Derek, are you ready?
Yes. Good afternoon, everyone. So today I'm going to kind of pull back the curtains a little bit on what happens for the crash data from where it comes into the state from the officers and makes its way over to the DOT, and how we do some calculations over here and provide it back out to our customers and the public. So ultimately, our goal is to reduce crashes, fatals, and serious injuries on our system. So safety data really helps us target our investments to make these informed decisions to reduce those types of crashes. I've been trying to wrap my head around our data governance maturity model. So this was a long effort, either last year or the year before last. It kind of blurs, but one of the areas that we were lacking in was awareness and outreach. So I've kind of put in the back of my mind, like, hey, I want to do a webinar eventually to discuss kind of what's happening to the crashes as they come into the state and ODOT processes them to try to find a location. There's some other ones that I'm currently working on as well, and I'll touch on a couple of those as we go through the day. But ultimately today we're here. So what happens when it comes from the officer over and potentially gets into GCAT? So there's a lot of things that happen in between those two areas, and I'll try to discuss a few of those today. So just to go over the high-level process, we collect crash data from, I think there's over 900 reporting agencies. About 69% of them are electronically submitted to the state. Well, there's not 69% of the agencies are submitting electronically. That's the volume of crashes that come in electronically. We're still getting about 30% paper forms. So those are keyed by vendors or DPS staff, and then ultimately makes it into DPS's repository. I'll touch on the officer crash mapping tool at the end of the webinar, if something we're working on currently. But after ODPS approves and validates all the data, then we essentially get an exact copy of their database over here at the DOT. So moving into DOT land, we're really looking for location, because once we have a location and can link it to our road inventory system, we have the ability to then add attributes that connect to other assets on our system fairly easily, and understand how either those assets are contributing to crashes or how those assets are mitigating crashes and preventing injuries. So that's our ultimate goal here. We have today I'm going to focus on the logging of crashes. So the first, does my mouse point? Can you see my mouse?
I can see it.
Hopefully. Yay! Okay, so I'm gonna focus. I didn't draw a box on the screen. It's later. I forgot. Focus over here on the logging portion, and then just discuss high level a couple of the calculations for examples of how we calculate additional fields that aren't necessarily on the crash report form, but we use to make engineering judgments. Ultimately, we serve this stuff out to lots of different tools, so safety analyst, hopefully Power BI in the future, GCAT and TIMS, and then our BI reporting tool that we use internally. So there's a lot of work in the middle, and then you can just keep adding on different tools at the end. So to discuss just a couple of examples of the calculations that we add value to the crash data, ODPS conducts a few for us, so like the bicycle, the motorcycle, the speed, those are fairly easy ones and universal ones that a lot of agencies need at the state, so DPS is already calculating those for us. So these are the ones that we get without doing any extra effort. Thank you, guys next door. But ODOT does add a few more additional calculations. So with the 2012 form, we're calculating that a driver was distracted, and that's internally or externally based on the new reporting form. We wanted to separate out fatigue driver. Before we had a fatigued distracted driver field in the old SHSP, so now we have both distracted and fatigued, and then calculating roadway departure based on federal highway standards, intersection related, and obviously nobody can agree on an age range of when people should be driving, so we calculate a teen driver that includes 15. If I flip back, you'll see that the youth driver started for 16 with DPS, and they have a teen driver that started at 13. So sure, but this is what is used in the SHSP. So to go a little bit deeper into the intersection related calculation, on the 2012 form and even on the new form that's coming out next year, there's the officer is able to indicate that the crash was intersection related. So if for the ODOT intersection related flag, if an officer indicated that it was related, we leave it that. Like we trust him, or that's solid. But there's some additional things that kind of to an engineer says, well, it's probably what we would call intersection related. So if the crash happened at a 4 approach intersection or at a T intersection, we would probably assume that something at the intersection could be contributing to the crash, as well as if the traffic control was signal, yield, stop sign, and finally if the unit failed to or ran the stop sign or ran the signal, those would also be considered intersection related crashes for ODOT, and I would hope most engineers. So that's how we calculate the intersection related flag. I'm going to go into crash type because I assumed if I wouldn't do an example of crash type, I would get yelled at and people would ask questions and I wouldn't be prepared. So there are 55 steps in calculating our crash type, but there are additional turn codes that we calculate that are used, and I'll show you a table just for left turns. But so we calculate a left turn, a right turn, no turn, and a U-turn. So this is based on the units from and to directions. So if a vehicle is headed from the south and going to the north, that's a no turn direction. So he's not turning. If he's headed from the south and to the east, he's making hopefully a right turn. If I get my cardinal directions correct. And then we always use the first 2 unit to calculate crash type. The first unit in ODOT's land will always be the at-fault unit because that's the one we're assuming all of the on and at information is associated with. So, but again, these are just kind of excerpts of that 55 sequential calculations. So first we do all the single unit crashes, and then we go into multiple unit crash types. And we're really just trying to make the manner of collisions more helpful, more understanding, because every time I ask a person what the difference between a rear-to-rear crash and a backing crash is, nobody knows the answer, because if you're getting rear-to-rear, weren't you backing anyways? So these are the standard MUT codes that are on the crash report form, and we're just trying to make them more useful for our daily operations. So the first step for just a left turn crash calculation was the pre-crash action of Unit 1 or the at-fault vehicle making a left turn. So if the officer coded that car in a 2-car crash was making a left turn, then we mark that down as a left turn crash. Then we go into the giant table. So every option of left turn, no turn, right turn, U-turn are included in this table, as well as a from comparison of the first two units and the to comparison of the first two units. So if you look at the picture in the bottom right-hand corner and we go to the fourth line of the table, the blue car is unit 1 and the green car is unit 2. So the green car the blue car is making a left turn and the green car is going straight. They are headed in the from directions are both opposite. So the green car is from the south and the blue car is from the north. And then their final directions would be, the blue car would be to the east and the green car is headed to the north. So those would be an angle approach in crossing movements. So if you add all those together, left turn, no turn, opposite angle, you end up with a left turn crash, and this table is 3 to 4 pages long. So this is not the final step, but there's one more thing that we look at if it doesn't end up getting caught in that table, but it pretty much has to. Only ones with the unknown travel direction would end up getting passed to the later steps. So then if the unit 1 in a multiple unit crash, if the unit 1 turn code is left turn, we would still mark it as a left turn crash. So that goes into somewhat the complexity that we use to calculate a crash type here in Ohio. And this is new. So if you looked at our 2001 criteria for left turn crashes, there were about 10,000 that were being coded, and the rest were either angles or head-on or some other of the 18 crash types. I have a giant matrix that kind of passes where they went to, but these, in general, we ended up with just over 28,000 in the new criteria of left turns, and I think that's intuitively what we expected. We knew we were missing some left turns. They were mostly coming through as angle and head-ons, and we were okay with that because as soon as you dived into the either collision diagram or crash report, you would pretty easily find out that, yeah, most of these guys are trying to turn left just based on your site type. Or even just looking at your site, you could understand these are probably angle crashes resulting from somebody trying to turn left. But now our data reflects it a little bit better. Finally, to hit on one other thing that was in the maturity model, I'm working, hopefully in a year I'll get this done, to put all this down into a document in English form. So here's an example of the roadway departure calculation. So essentially it gives a definition, it describes the calculation, and then it gives you the code values and whether you can clean this up with a hand log or crash data cleanup process. So hopefully this will help with some of our transparency on what we're doing behind the scenes. I might give this to Caroline. Hopefully she doesn't kill me. So with that, that's kind of an overview of those added value calculations and a couple examples. I don't know, Victoria, if there were any questions in the chat pod at this moment.
Just a question wanting your PowerPoint, and I told him I would email it out afterwards.
Okay.
So we're good.
Perfect. So here should be animation. Yay. Okay. So the rest of this presentation, I'm really going to focus on these items, how we log crashes, and then where we're going to in the future. So, but ultimately, once we log a crash, we're able to connect it to multiple other sources here at the DOT and provide additional information. So we can understand what the volume is on that roadway with that crash, or we can understand if there's guardrail in that piece of road or along that piece of road where that crash occurred. So ultimately, we have these crash locating processes, and I'll walk through each one. But in general, you have, we're trying to get more crashes off of the interstates or the arterials and onto ramps and interchanges. We still have from the 2001 form to the 12 form, and even on the 19 form, we just have 3 reference types: intersection, milepost, and addresses. We've added this interchange logging, which I'll discuss, and of course we can always revert back to what the officer said, and we kind of use that intelligently throughout these other processes as well. The last thing is more of a cleanup for logging. So whenever we have a divided roadway and we try to get the crash to be on the side of the road that the car was actually traveling, the at-fault vehicle. So to go into each one of these, there's ramp crash logging, and we look if the officer said the crash occurred on a ramp or on an off-ramp, and his officer's coordinates are within 250 feet of that inventoried ramp, we will allow that lat long to snap. So we've kind of done completed a little bit of validation on the officer's lat long that, yeah, he's not at the hospital, he's not somewhere where we like to think officers hang out. He's actually close to the a facility that he said he was at. So that's the first step, and it's the first process that we run in our locating system. Then we go into these reference types. So every crash will be pigeonholed into either intersection, milepost, and house numbers. Intersection and house numbers operate fairly similarly. So we clean up some of the street name information, common abbreviations. We change the 911 road type. So the suffix for boulevard for 911 is BO. And in every mail system, it's BLVD. So we do all that translation, and then we send that information over to OGRIP, the state GIS agency, and we use their geocoding services to provide us back a lat long. And so if that lat long falls within 250 feet of a road or an intersection, we'll allow it to snap. But we don't just allow it to snap. We use some intelligence because we have other information. And this is where part of the old system lacked. So we can now use street name, but so as we get the lat long back, we can look to say, hey, does that lat long find a street name within that 250 feet, or does it match the route prefix, route ID, and suffix, and all these combinations down in a hierarchy. So it gets kind of a score, and then the best closest match wins. And that's how we're trying to geocode. And then we would calculate the offset distance direction after that point. For milepost, it's a kind of a two-step process. We've inventoried a lot of the milepost signs across the state, especially on non-interstate routes. The interstate routes don't change much, so their log points are the log point matches the milepost that's out in the field fairly frequently. So here's an example on 161 where within 200 feet I have a state milepost and a county milepost. So we have both signs inventoried. It's treated just like an asset to the safety and crash systems. So it is brought forward each year to match our LRS, and so it's a fixed asset to us. It's not really anything that moves around in space. The reference point moves. So we've inventoried a lot of these signs. The way we usually catch them is an officer starts using them, and we don't know, it'll come out in the data cleanup portion that we do in our office. So like when they posted Cross County Ronald Reagan Highway signs with an RR and a milepost and confused everyone in our office, we were able to inventory those and know what it means. But the second step really is the milepost should be fairly close to the log point that we have inventoried on the LRS. There are some exceptions, and that's where we make sure that we have those milepost signs inventoried. But if it's valid within that county for that log point range, we'll go ahead and snap that crash to that log point. For interstates and turnpike, we do allow it to cross county lines a little bit because it's blurry at where that line is on the interstate at times. So we'll give them a little bit bigger buffer. We do, for both intersection and milepost, we do a little additional processing for interchange crashes. So if the reference point for intersection or milepost falls within an interchange, we then check to see if the officer's coordinates also falls within that same interchange. And so if it does, if the lat long falls within that interchange, we will allow the lat long to snap to the road. Again, with that same logic of was it on 70 or was it on Broad, and then snap to the right road, or even to the ramp if it's close. Then, so that's how we're getting things off of our interstates and arterial system and finally onto our ramp, so we can understand, like, this looks like there's a collection of crashes occurring on this ramp for the curvature, and maybe the pavement condition. And when none of that works, we revert back to the officer's coordinates. Now, we will say these are getting better, and we appreciate the efforts and the outreach that everybody's done to say, but we know that we want that officer out of the way of traffic to keep traffic flowing and for his safety. So our reliance on this is still fairly low, but it does happen, or it is used if either when we validate it with a previous step or finally trying to find a road that it matches against. And we can look at the data, and ones that don't snap with, like, so if it doesn't match any of these names or anything and we're using that long, we're planning to do additional cleanup to try to make it match a little bit better. So trying to fix the geocoding process so it actually can find the intersection because it didn't find the road that it occurred at with the officers that long. So the final step in our logging process is this directional logging, and this is instantaneous direction. So we digitize our roads typically from west to east and south to north, and so therefore we can use geospatial tools to understand the direction of the road that's happening kind of in that point in space. So essentially the bearing of the road where the crash occurred, and then compare that bearing of the road to the direction of the vehicle's travel. So if the vehicle was headed from the west to the east and the road was bearing to the east, we would leave it on the cardinal side or the eastbound side of the road. If the car was headed from the east to the west and the road was headed to the east, we'd flip it to the non-cardinal side or the upside, or there's a lot of terms for the other side of the road, but essentially the line string that goes from east to west. And this is helpful when a road curves. So if this is 270 on the east side of town, if at a certain point the road's east and west, but another point it's north to south, and so we're able to kind of estimate which side of the road the crash should be occurring on. And when in doubt, we just leave it on the cardinal side, or it'll always be on the west to east or south to north side. So at times there'll be errors where either the direction is not known of the unit, or the unit's direction doesn't match, or the unit's direction, it always has to either match the cardinal or it gets flipped. So the unknowns are the ones that kind of get left behind. So that's how we internally run some automated processes. We do have tools that allow us to take some of that cleaned up data, or take the data in its raw form, do a little bit more cleanup, and submit it back in and run it through that entire weekly process again, without doing a ton of effort. It still takes time, but so that's an ongoing process. But this process I want to detail next is really the crash data cleanup. It used to be called hand log process. We're hoping crash data cleanup kind of sticks because we're really trying to improve quality, either location or one of those calculated attributes. So this is really when you don't like a location of a crash or you don't like a calculated attribute, you can submit this to us. So what calculated fields can you change? So we really don't let you change any of the teen driver, young driver, the pedestrian and the bicycle ones are calculated by DPS, and we want to make sure our counts match their counts, so there's no discrepancies between agencies, so we don't allow those calculations to be changed. But anything that really has to do with the engineering countermeasures, so crash location, intersection related, and roadway departure, those are things that we screen on regularly, and so we want to make sure that we have the most accurate data. And then everything location. So we have added some flexibility in how we get that information, but we definitely need the document number or whatever they call the unique identifier in the next crash report form. The cleanup type, I've kind of talked to Caroline and Mike, and we can make some judgment calls, but there's one that I'll help identify on the next slide. Like, if you want it to be this, please let us know in some form or fashion. But we're really looking for LFID and log point or lat long, so we can take both, and then street name cleanup and route information, so we can help snap that lat long back to the road more efficiently and appropriately. So if you're just providing LFID and log point, there's probably no reason to go clean up the street name and route identifier, because you're already giving us that this is where it is, and we'll check to make sure that that log point exists on that route in that county. But other than that, we're trusting the source. And it's always, with this crash data cleanup, it's always the last thing we process. So if one week the district gives us one thing, the next week somebody else gives us a different thing for the same crash, we're just going to overlay the next thing. We're not in the game of cleaning it up. Hopefully that they're coordinating that effort, so that we don't get crashes like we're updating it one week and then the person doesn't pull it down, or pulls it down in the old form and still cleans it up again. But we're just trusting that some of that's taken care of that by individual agencies. So for the lat long cleanup process, this is where these type codes kind of help, and you can. This is mainly, if we don't know which one it is, we'll probably ask you, so you might not have to worry about this. But essentially, if you give us a lat long, we're going to allow that lat long to snap to our road inventory if the lat long falls within 250 feet of our roads. And we'll do all that intelligent snapping that's using street name, LFID, all these things, if you provide it to us to snap to the right road. There is also the option of you give us a lat long, but the road it happened on doesn't exist in our inventory, and we don't want it to snap to anything close. It didn't happen at the intersection with a different road, so it's really not appropriate to snap to the road inventory. And so we're allowing you just to provide us a lat long, and we can indicate that one, that just take the lat long and don't snap it to anything else. And then finally, you have the option to remove a location. So this crash is not in the right location because we found it, and it's the information provided by the officer. We're not able to find it. We're not able to relocate it. So this one's pretty much, in our office, we pretty much say, we never want to look at this again. We've tried. It's done. And so we're putting it to bed. We're going to make it this, and all of our queries will not pull out that crash to be reviewed. Kind of discuss that thing again. It keeps popping up. One thing, Shirley was a stickler. Mainframe was fairly inflexible, and it was difficult enough to get the data into mainframe to get it updated. Where the new system is fairly flexible, there's a lot of QC checks that are programmed for us. So we will take your data in any electronic format you want to give it to us. And we're not picky. We might have to ask some questions. But essentially, if you're willing to clean it up, so if you want to clean it up in GIS, move your points around, and then give us a shapefile, that's fine. If you want to export it to a CSV, that's fine. We'll take whatever you want to give us as long as it's improving our data quality in the end. So we'll work with you if to make that less burdensome on you in the future. So now I'm going to walk through a couple examples of crashes in the lake. Cleveland's still paper, so there's not a lot of validation that we can do. Also, Cuyahoga, any lake bordering county, the county line boundary technically goes all the way up to the nation's boundary, so it incorporates a lot of the lake. So we can't say that these don't fall within Cuyahoga County. They technically do, it's just in the lake. So I took these two crash reports. My example will include snapshots from the CAM tool. Like I said, that's our preferred kind of method for cleaning up crash data. We're working to revamp that tool, and we'll send out a survey to our users, hopefully probably after OTEC and during safety applications. Well, So you have time to complete that, and we have time to review safety applications. But essentially, the detailed example I'm going to walk through is actually the second line, but I wanted to keep both crashes in here because there are some unique things that I can discuss. So mainly focused on the second line. So if I look at the crash report form, the officer indicated that this crash occurred on Crocker Road, a tenth of a mile south of American Boulevard. So thankfully, Google knows where American Boulevard is because it's not in the state's data system. And it's a good reason why, because it's under construction. So the east side of this road was was Corporate Park, and the west side of the road is that new American Boulevard. But Google knew it was coming in. So I was able to find it in Google. But then I went one step further and I go, okay, let me read the narrative and look at the diagram. So I see he was definitely headed northbound, so that confirms what he wrote at the top of the form. And the diagram also shows that he was on the southern leg of the intersection on the inside through lane, but we don't really have that availability of detail. So all I did was click in Google Maps a little bit farther south, right click, and you can say what's here, and you'll get this little flag at the bottom. And then you can copy your lat long out, and I paste it into the cam tool. So you can see that lat long matches the second row of the screen cap from the cam tool exactly. So you can stop there and send us that information, and we will gladly try to snap that lat long intelligently back to Crocker Road. However, if you want to go one step further, you can go into our DOT mapping application and actually find the NLFID and log point. So what you do is I like to turn on the layer under road inventory called LRS, and that actually will show this blue line. So any road that we have inventoried will be under that LRS bucket. And that way I know my roads that are available. So if it happened on American Boulevard, which it didn't, I would at least know like if it's available to be snapped to or not. Like, why does it keep snapping over to Crocker Road? Because I'm clear, like if I click over here, it would still snap to Crocker Road. And sometimes it gets frustrating. You're like, oh, there's no line there. So we like to turn on that event layer. And then the second tool bar, the dark toolbar up at the top, you can do find log point, and then you'll select click on map, and you just click kind of exactly where that lat long was before, and copy out the NLFID and county log point and submit that back to us. All of our systems rely on the county log point, unless they're like the mileposts automated weekly process does use state log point systems, but when you're submitting hand logs, we definitely want this county log. We would likely know, unless you're in Hamilton, a border county, if you're giving us something other than the county log pretty quick. So essentially you record this county road 450 at log point 3.461 into the cam tool, the second line. So that, if you do that, you don't need to update anything else in the cam tool, unless you want to correct a countermeasure. But if you only give us lat long, here's an example of, for these two records, of some misspelling, which is probably why we didn't find the first one. So we have a process to correct CTR to center, because it's a common abbreviation. However, they put a space between the T and the R, and so we had no clue what that was. So if you want to, you can come in here. If you've given us a lat long, you want to change it to Warrensville Center Road. And that way, when we come back, we'll actually be able to snap your lat long to Warrensville Center Road, not just the closest line string. I went through and looked at these crashes as well for roadway departure, intersection related, crash type, and ODOT location. So the crash type of the first one was animal, which was just weird. So obviously the officer coded something wrong. He likely meant that the at-fault unit was unknown, but put the at-fault unit to be an animal. And then the second one put that it wasn't at an intersection, but it was at the future intersection, or the current intersection is a four-way. It used to be a T, but now it's a four-way. So all this information we can take back in and apply back to our road inventory or our crash system, and then hopefully connect over to the road inventory system. And finally, just to hit on things that we're currently working on the data end of things. This is Mike and I's like little pet fun project. Is we want the officers to like be in their cars, out of the way of traffic, and be able to click on a map and get our road inventory data. So we already have a prototype done working with DPS. It was coded completely internally with ODOT IT and DPS IT. Oops, sorry. And so essentially they'll click on a map and it will pull up the roads that are within 250 feet of where they clicked. And then they'll select which road the crash occurred on. And then we give them back the correct city, the correct county, the correct CVT code. We actually they'll store the NLF ID in LogPoint for us. And so we're providing better information back to the source, so there's less cleanup we need to do at the beginning, or once it gets over here to ODOT. The other thing that we're working on diligently, and we have it internally, we're working on getting IT resources and getting in the pipeline for a project to put a Power BI dashboard externally. So here's an example of just our performance measures, so fatal, serious injuries, and non-motorist fatal and serious injury performance. So this is a 5-year rolling averages, and this is the completed one for 2013 to 17. And so you compare, we were always at 1% reduction, so you compare what we had in 2011 to 15, take 99% of that, and that would be our target. And obviously we're higher in 2013 to 17, so we did not meet our target for the last year, and you can kind of do the math for the rest. But the nice thing about Power BI is it's very easy to localize it. So here's that same exact dashboard that I made for the state, had to calculate for the state, and just as a byproduct of the data, you can easily roll it down to the county, the district. Here I've filtered on the MPO of LCATs, and you can see kind of that performance for that MPO. And for our office, we did no extra work because we had to do it for the DOT, the state level anyways, and we get all these additional benefits for local agencies. Kind of another example of that is SHSP emphasis area dashboards. So this is one for alcohol for the entire state, kind of discussing where they're occurring on what types of roads and how many lanes they are, when they're occurring, during night or dark, and then also what the road condition was. But again, kind of the same thing, filtered on Summit County. You can go see, well, in Summit County, what do my crashes look like for that same emphasis area, and you'll be able to see how it changes. So they're probably some of the big types of roads, but maybe the number of lanes of the roads, or maybe the hours change slightly depending on local bars or watering holes. I don't think the dark light, obviously we'd have more snow crashes as the farther north you get. Another one which I really want to get out this year, but probably won't happen, is this kind of reporting status dashboard. So this lets all the reporting agencies know how many crashes we currently have in our system for an open year and compare it to kind of an average 5 years past history. So the reporting threshold changed in 2011, I think, 11, 12, somewhere in there, up from $400 to $1,000. So the 5-year rolling average should be fairly accurate on how many crashes we'd be expecting. So you can see for the entire state, this is the monthly trend on how many crashes we have a month, every month. But the cool part is, if you want to go into your individual reporting agencies, you can kind of see how it lags for different agencies. So Cleveland, again, not to knock on them, their paper reporting. So as of the first of this month, we had 1 crash for the entire month of August, where if you're electronic, we pretty much have most of your crashes in the system for August once we start into September. So different, depending on which region you're in, you can use more timely data versus some other regions you might have to use or understand that it's lagging some. Finally, I think this is my last slide, the crash report form will be changing. It's definitely going, I think they're guaranteeing it's going to be available. Software will be available in January 19, so all the upgrades. And then there are two things that are exciting, that we'll have like a desktop version. So if a local agency wants, like, if they don't have a lot of crashes, and they have an operator in the office that want to key in the crash reports to get them into the state, that will have that option to get better data. So the person entering the form, the local person, when they type in and see that the lat longs in a different county, that validation step can happen and can then inform the user like, hey, you've mistyped something potentially. So so the officer crash mapping tool will be available first thing for anybody using, for patrol and anybody using OLEASE, the DPS reporting software that at least our feed out to the web service from the DOT is publicly available. So if a vendor wishes to ingest that service and create a mapping application for a vendor source, it's already built and constructed and they can use it. We'll give them a different key to access and make sure that uptime, like we have a super high uptime of that web service. So with that,
I've got a question for you. Just came into the chat pod. It says, you mentioned that the crash report form will be changing. Will changes be made that address cyclists during crashes? During crashes are very difficult to track, even though they are one of the most common cyclist crash types. Thanks.
So we have, the intent was there when we wrote the crash report form. However, DPS's definition of what a crash is unwavering. So a motor vehicle has to be in motion for it to be considered a crash. And I believe that's a combination. I don't know. It's very complicated. So essentially, doorings typically happen with a parked vehicle that's not in motion. So we will not be getting during crashes.
Got another question for you. Can the public get the ODOT derived crash type, or is this only available in GCAT? The field is in the ODPS track tape data, but is blank.
Yeah, okay. So yes, crash type is publicly available on TEMS. So if you go not into the crash data search area, but you go into just the create a map area, there's a limited number of things that are available, and crash type is one of them. Severity is one of them. I think date, month, some of those. So I think it's limited to like 6 to 10 attributes are publicly available. Again, we aren't the source to the public, so we want DPS to be the source. That way, if we've changed something, which we try not to change anything that we get from DPS, but we definitely change location information. So back to the DPS side of why it's not populated, we're working on that. We're not sure what's happening, but their IT is now aware of it. We still give our information back to DPS, so we're hoping that we can get that corrected, probably with the rollout of the new crash report form. So probably not this year yet, but hopefully next year.
There was a second part to that, and I'll read it, but you may have already answered it. Is the traffic control type in the ODOT road inventory? I would like to be able to evaluate the safety of things like RRFBs and PHBs. And then the same person put another message in, thank you for working on dooring, crash type, etc.
So I believe the interim rule requires us to keep track of where all the RRFBs are located. Those will probably be lat longs, and I don't know. I've tried, I'll work with road inventory a little bit closer, but they're the official repository for RRFBs. Hawks, I believe, is the other type. I forget, BH, I forget what it is. Anyways, those are, I don't think they're inventoried that well. I don't think they're required to be inventoried, but I could be wrong. I would lean towards Jordan, probably following up on this question. but any of the intersection traffic control will now be able to maintain. So moving forward, as of this month, last month, August, so we'll be able to keep track of that, and if something's wrong in our database, update it, and then the next year will be improved in our crash analysis for like our network screening and anything to do with modeling. So we're getting there. I think one of the types, the RRFBs, I know for sure we have to get inventory. I'm not sure about the other one.
Great. Well, if there's no other questions in the chat pod, I'm going to go ahead and open the phone lines up for questions. So if you have a party going on in the background, like my cube mate just started doing, please go ahead and make sure they calm themselves down, because I'm going to go ahead and unmute everybody. And if you need to, you can unmute yourself now on the system. I'm going to unmute additionally individually each of the folks that called in.
I tried to leave 15 minutes for questions, so I was hoping I would confuse people at least at a minimum.
Well, I'm unmuting them, so if they have questions, they can go ahead and start trying to chime in. Like I just unmuted the city of Cleveland, who might want to talk to you about your examples that you had there, Derek.
I think a lot of the Cleveland issues is just some of it's handwriting, some of it's transposing the numbers. We still have issues with multiple agencies of the difference between degrees, minutes, seconds, and decimal degrees. So we pretty much know if you use degrees, minutes, seconds, and the minutes are over 60, that we're just going to assume that that's decimal degrees and you wrote it in the wrong blank. So we see a lot of those errors, and a lot of that doesn't get edit checked because you're not electronic. So, but we're aware of it, and we try to help clean up a lot of that stuff.
Okay. Everybody's unmuted now, so if you have a question you'd like to ask Derek, please feel free to go ahead and ask him.
Or if you want to say, was this helpful? Should I have another one with something more in depth? We're really trying to help make aware of what we're doing here, so it's not, so when you get to a crash, you're like, how did Derek get this here? How did ODOT make it here? We're a little bit more transparent in our locating process.
I can't imagine that no one on this call has a comment.
Hello, Derek. This is Eva Vargas in Cleveland Engineering and Construction.
Hello.
Hello. Yeah, I have a question for you as far as, as we go through our own cleanup of data and we look at certain things and find that certain accidents aren't recorded where the report says they are, do we send you that kind of information also, or, because we're I guess for your purpose, we're an outside agency, so I wasn't really sure how that works.
Yeah, well, I'll take data from anyone. So if you're moving the crash, so like it's easier on us if, well, there's two ways that kind of help us. One, if you just give us that document number in either NLFID or lat long, that'll help us get the crash to the right place fairly quickly. The other thing, if like all the crashes at this intersection should go to this intersection, that one's a fairly easy one for us to fix on our own. Kind of did a couple of those for Summit County in recent times. So if you find a big group of crashes, even if you find a big group of crashes that potentially have one of the calculations that you're just not quite sure about, like crash type all came up unknown, and you're like, well, why is this? Go ahead and send that to us. We're working on, so Caroline, and I'm trying to work because Shirley retired. Yay, Shirley. Good for her. I'm trying to work with Caroline to help me out with some of these tasks, and in case something drastic happens with me, but I don't feel I'm not leaving anytime soon. But at least there's some cross training, and things stay more current if I have some help. So we'll take, like I said, we'll take your data from anybody that wants to give it to us, and we'll help you if you're willing to do some work, if you want to ask questions up front before you start the process, and then go at it. We're willing to help with a little meeting up front to make sure you're on the right track as you go down that path.
Thank you.
Yep.
Who else on the line? Go ahead.
Cleveland.
Hello.
Since Eva talked, she inspired me to say something. I'm normally very shy and don't like to speak up. I asked the question about dooring, at least the first one, and I'm, I'm very frustrated by the fact it's so hard to track those. It's my understanding that if a motor vehicle crashes into another parked motor vehicle, and it's a property damage only crash, it's very easy to locate or track that kind of crash because one motor vehicle was in transport. And if anything I say is incorrect, stop me anytime. But if a cyclist crashes into an open door and they're killed as a result of that, it's not easy to find that information because the cyclist is, although they're using a vehicle, it's not a motor vehicle. I don't understand why that distinction is so important between whether you have an engine on your bike or not. I guess a motorcyclist or someone on a moped might be tracked, but not the cyclist. Why is that not being changed to account for just regular cyclists?
Uh,
And I'm blaming
the way I looked at the parked vehicle, so this is a clear interpretation by public safety, and I tried to express the opinion and the need for this as well. And their legal team has looked at the interpretation of the Ohio Revised Code of what a motor vehicle is, and so what a motor vehicle is not a bicycle. A bicycle
True.
is not one. True. So just a fact, like if a bicycle crashes on its own or hits a signal pole, that would not get into our crash data either. The fact that their interpretation of what a motor vehicle in transport is public safety's interpretation of that. And everybody can have opinions, but the people requiring the reports and doing the reports are the official ones. We can only voice our opinions and try to guide and describe uses, which we've done a lot from the DOT's perspective and engineering perspective for the next crash report form. So we hope the things we've done to the new crash report form, like one is just intersection or on approach to intersection, hoping to get more of those intersection related crashes identified by the officers. Trying to clean up some of the things that will never occur. So you're never going to have a railroad crossing in certain circumstances with signals or different things. So we've tried to, but this one thing is a pure interpretation by DPS, and I tried, but I can't help anymore. I'm sorry.
Okay, thank you.
Yep. Jordan's tried. Caroline's tried. We've all tried, I think.
Yeah, Derek, there's a comment in the chat box from Tricia, and she said that her understanding is that actually comes down from NHTSA and GHSA, and that they tried to get the change into the NHTSA standards, but weren't successful there too.
Okay. Yep, we're a supporting agency as this role, but at least they listen to some things as if it's valid.
Who else would like to ask Derek a question or provide him feedback on future topics that you'd like to hear? We've already had one comment in the chat pod about a future webinar and learning more about how the crash types are derived.
Okay, I'll have to learn too. Again. I can speak to some of the new things on the new form. If anybody wants a copy, I can email you out a sample copy if you just send me an email. But that's
Would I
probably
be
the
able
easiest
to
way.
just send it out with the link to the webinar?
Yes, we can do it that
Great.
way. So like we have a secondary crash flag, and we're actually helping the procedures manual. So that's a lot of this. We also have input on how the procedure manual for the crash report form. So helping describe some of these things, especially the intersection related ones, what a secondary crash is, we've gotten rid of all the headings on the unit pages. So for the most part, if a bicycle's headed down the road in the pavement acting like a unit, and his pre-crash action is making a left turn, the pre-crash action will be coded as left turn, not like bicycle in pavement, or I don't even remember what it used to be. So like a lot of the non-motorist contributing circumstances and pre-crash actions and actions can all are treated equally to motorists now. So some of the things for non-motorists, like reflective clothing, will not be allowed to be used for a motorist, because I guess you could be in your car with a vest on, but it really didn't help in preventing the crash. So things like that, that'll help us better understand where these non-motorized users are in relation to the motorized vehicle. We broke out a lot of the intersection types and the median types because some of the combinations on the unit page weren't really helpful. So we brought that over to the crash report page. So the crash happened on this road. Is there a median? Before, it's every unit would have, is it a two-way roadway? Manner of collision pretty much stayed the same. Sorry about that too. I think that's the major changes on the first page. Did we get any more questions?
We didn't, and we've only got about 4 more minutes left. So,
okay. I'll stop rambling.
It's all right. If there's no more questions from the audience, I know we don't have any more in the chat pod, we'll go ahead and wrap things up. But Derek, thank you so much for doing this webinar today. We really appreciate it. And as long as the recording's successful, I will send a link out to that along with a copy of the PowerPoint and the crash data form. So,
right. Thanks, everyone.
Thanks, Derek. Thanks, everyone. Have a great afternoon.